All right, so our last class meeting, we talked about what a mid-segment was. And just to review, a mid-segment is a segment connecting the midpoints of two sides of a triangle. And we said a mid-segment has two important qualities. A mid-segment is parallel to the third side, and a mid-segment is half the length of the third side. So if this is your mid-segment, it is parallel to this third side, and it is actually half the length of this side. So if this is length A, this would be length 2A. So today what we're going to do is we're going to actually spend a lot of class time proving those two things that are true. So let's go down to the bottom part of your notes here that we didn't talk about. And the first thing we're going to do is I'm just going to go ahead and show you that DE is a mid-segment of triangle ABC. So a mid-segment, obviously it has to be the midpoint, and it's pretty easy to show that E is the midpoint of CB. We can simply count. CB is 1, 2, 3, 4, 5, 6, and clearly E is 3 spaces from C, 1, 2, 3, and 3 spaces from B, and 3 spaces from C. So E is clearly the midpoint of CB. But it might be a little more difficult to show that D is the midpoint of AC because it's not on a vertical or horizontal axis. Of course, we can count up 1, 2, 3, 1, 2, and up 1, 2, 3, 1, 2, and hopefully that is proof of a midpoint. But we have another way of showing midpoint, which is the midpoint formula. We can take any 2 points, plug them into the midpoint formula, and find the midpoint. Hopefully you guys remember that from Math 1. So let's do that right now. So I'm going to write the midpoint formula, which is simply x1 plus x2 divided by 2. This will give you the x value of the midpoint, and you can see that hopefully you can tell it's just the average of the two x values of the endpoints, and then y1 plus y2 over 2 will give you the y value of the midpoint. All we're doing is we're taking the average of the x values and the average of the y values, or in other words, the average of the two endpoints of x and y, and that will give us, in this case, midpoint D. So the x, you can see what we're doing is we're finding the midpoint of the difference of the two y's, and then we're going to find the midpoint of the difference of the two y's, and that'll bring us right to D. Okay? So C, we don't have it, but we should realize that it's 0, 0, right? So it's going to be 4 plus 0 over 2. And then it's 6 plus 0 over 2. I'm sorry, 6 plus 0 over 2, yes, because we're taking the average. So the 4, oh, I'm sorry, right there, 0, right? My mistake. It's 4 plus 0. What we're saying is 4 plus 0 divided by 2 gets us right there to the x value of D. And then we're saying 6 plus 0. 6 plus 0 divided by 2 will get us to the midpoint y value. So when we simplify this, D is at 4 divided by 2 is 2. 6 divided by 2 is 3. And the midpoint D is at 2, 3. All right, that's the midpoint formula. So now we can say for sure that D is the midpoint of AC and E is the midpoint of CB, which means that the line segment DE is definitely a mid-segment, isn't it? Okay, so we can say these two guys are congruent, and we can say down here these two guys are congruent. So DE is a midsegment of triangle ABC. All right, now we're going to go about proving that the midsegment and the third side are parallel. Does anybody remember how we talked about lines being parallel in the coordinate system? Toby? The same slope. If two line segments have the same slope, then they are parallel. So now we need the slope formula. So the slope formula is, you should remember this from Math 1, it's y2 minus y1 over x2 minus x1. Sometimes you hear it as delta y over delta x, or the difference in y's over the difference in x's. All right, well, let's find the slope of DE first. So let's go ahead and write these points up here. D is at 2, 3, and E is at 3, 0. Now, y2, y1, it really doesn't matter if you choose this as y2 or y1, because what's important is that they go together. If you're going to call this y2, you have to call this x2. If you're going to call this y1, then you have to call this y1. I'm sorry, x1. Because I could just as easily write D over here. Doesn't matter the order you put things in, you just have to keep them together. Okay? But I'm going to call this x1, y1. I'll call this x2, y2. And now let's plug it in. So let's find the slope of DE. So I'll put M for slope, and I'm going to put little DE here. And it's going to be 0 minus 3 over 3 minus 2. And we end up with negative 3 over 1, or simply negative 3. So the slope of DE is negative 3. And of course, this is an easy one. We could simply just count, right? Down 1, 2, 3 over 1. Down 3 over 1. Remember, because slope is rise over run. In this case, it's a negative rise, run 1. Everybody good with the slope of DE? All right, now we're going to find the slope of AB, and we're hoping, what we know is it should equal this slope, right? All right, let's write down the points AB. So we know that, I'm going to write them right here. A is at 4, 6. And B is at 6, 0. And now plugging them into the the slope formula. So we're going to find the slope of AB this time, which is 0 minus 6 over 6 minus 4. Which is negative 6 over 2, which is negative 3. All right, so we have a slope of DE equals negative 3, and the slope of AB equals negative 3. So what that tells us is line segment DE is in fact parallel to line segment AB, isn't it? Does that make sense? Pretty simple? All right. So we've proved that the mid-segment is parallel to the third side. Now we want to show that it's actually half the length of the third side. So before we do that, I want to talk about the distance formula, because that's what we're going to need to use to show that DE is half the length of AB. All right, to do that, what we need to do is talk about Pythagorean's theorem. So do you guys remember Pythagorean theorem? What is it? A squared plus B squared equals C squared. All right, for our purposes to to prove the distance formula, I want to switch it around. I'm just going to rewrite it as c squared equals a squared plus b squared. Does anybody have a problem with that? Anybody? All right, I just switched it around a bit. Now, what is the square root of c squared? C. Okay, good. And if we take the square root of the left, we have to take the square root of the right, and we end up with a squared plus b squared. All right, that's basically how we come up with the distance formula. So if we take a right triangle, remember Pythagorean theorem works with the right triangle. Okay, and I'm going to say that this right triangle is 1, 2, 3 tall. All right, and we're going to call this, we'll just call this point A, and we'll go 1, 2, 3, 4 long. We'll call that B, and then we will just connect the dots here, and we get triangle ABC, where A is at the point 0, 3, B is at the point 4, 0, and of course C is the origin 0, 0. Clearly a right triangle, correct? Is everybody okay with that? All right. So because you guys are smart, we could find the length of AB by using Pythagorean theorem, right? If you remember a right triangle, it's a squared plus b squared equals c squared, right? So we can find c by simply taking the square of a and the square of b and then square rooting it, right? Much like I did right here. So c is equal to the square root of a. What's a? How long is a? Can we count? 1, 2, 3, isn't it? 3 squared plus b is 4 squared. Okay, which means c equals the square root of 9 plus 16, which means c equals the square root of 25, which means c equals 5. Correct?
Yep.
All right. Now that one was pretty easy to count, wasn't it? We could just count it.
What formula is that?
That's the Pythagorean theorem.
Still?
Yep, still Pythagorean. All I did is took the square root of both sides, and instead of having c squared equals a squared plus b squared, I just took the square root of both sides, and I said c equals the square root of a squared plus b squared. Okay? All right. But, you know, not all right triangles are that easy, are they? They're not that easy to count. So let's go back to c equals the square root of a squared plus b squared. Okay. And I actually made them a little sad. I just want to make things a little easier. I'm going to call this A and this B, okay? I'm just going to switch their names real quick. So let's say we wanted to find the length of A, but we really couldn't because maybe our triangle, maybe our right triangle is drawn out here somewhere. And maybe it's bigger and it's not so easy just to count. And we can't just count this because that isn't on a vertical or horizontal axis. Well, what we could do is, instead of counting 1, 2, 3, 4, can't we just find the difference in the x values? 4 minus 0 is 4. So we can always find the horizontal length by just subtracting one x value from the other. Okay? Instead of counting 4, we could go 4 minus 0. It's 4, isn't it? What if we went the other way? What's 0 minus 4? It's negative 4, but when we square it, it really doesn't matter, does it? Because when you square a negative, you still get a positive. So instead of just counting, what we're going to change a to, we're going to change it to x2 minus x1 squared. Because a, we can either count or we could simply subtract one x value from the other, couldn't we? Are you following how I got there? Now, same thing works for b over here. Instead of counting, we could just subtract one y value from the other. 3 minus 0 is still 3, isn't it?
Yeah.
And again, if we went 0 minus 3, we'd get negative 3. But when you square it, you still end up with a positive. Yes?
Isn't that formula the distance formula, not the Pythagorean theorem?
Oh, ding, 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 ding. You're right. That's just the distance formula. Change that C to a D and you have the distance formula. Okay? Just basically what I just did is prove the distance formula for you using Pythagorean theorem. Okay? That is our distance formula right there. You need to have that memorized. You should have had it memorized for Math 1. Just wanted to show you where the distance formula comes from. Okay, now that we have it, we're going to use it to find the length of DE and the length of AB. Our premise is that AB is going to end up being twice as long as DE. So let's go plug in the information. So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Whenever you use the distance formula, I expect you to write that first before you solve. Every single time you need to write that. All right, let's plug in our info. D equals the square root of, we're doing DE first. So here's DE, so it's going to be 2 minus 3 squared plus 3 minus 0 which means D equals the square root of 2 minus 3 is negative 1 squared plus 3 minus 0 is 3 squared, and we get D equals the square root. Negative 1 squared is 1, 3 squared is 9, and 1 plus 9 is 10. So D equals the square root of 10. We don't need to do anything else there. That's the length of DE, square root of 10. So let's go over now and find the distance or the length of AB. Remember, we're going to write the distance formula first every single time. Plug in our information. Okay, here's AB right here. So we can simply go 4 minus 6 squared plus 6 minus 0 squared, which means D equals 4 minus 6 is negative 2, so negative 2 squared plus 6 minus 0 is 6 squared, which means D equals the square root of 4 plus 36. You need a little more room here, so D equals the square root of 40. But remember, 40 is 2 times 2 times 10, which means a 2 gets out, a 2 gets killed, and the 10 stays in. And we end up with D equals 2 root 10. And hopefully that's pretty clear that 2 root 10 is twice as long as root 10, isn't it? So what we can say is DE, the length of DE is equal to 1/2 of AB. So what we've just done using the distance formula is prove that DE is half the length of AB. That DE is half the length of AB. That was one of the things I told you yesterday. And using the slope formula, we've just proved that DE is parallel to AB. Right? And using the midpoint formula, we proved that D is in fact the midpoint of AC and that E is the midpoint of BC. All right? So if we turn the page We did this yesterday. We did 4.1b. I did the odds, you did the evens. These are some additional notes that we're going to use for review probably next week. At some point I'll assign those to you when you come into class. And this is what we're going to work on today. All right, so let's do this together. I'm going to work through one with you. Okay. So, using triangle JKL, JKL, answer the following questions. A, find the coordinates of the midpoint of JL. Okay, well here's JL, so we're going to use the midpoint formula to find the coordinate of the midpoint of JL. So here we go. So here's the midpoint formula, so I'm not going to make you rewrite it. So the midpoint of JL is x1 plus x2. Remember, it doesn't matter which one you pick as x1 or x2, as long as you pick the same for y1 and y2. So I'm going to go 2 plus 0 over 2. Then I'm going to go for the y's, 6 plus 0 over 2, and that will give me the midpoint of JL. And we're going to label that point M. So 2 plus 0 is 2, divided by 2 is 1. 6 plus 0 is 6, divided by 2 is 3. So our midpoint should be at 1, 3. And if we go 1, 1, 2, 3, we find that that is M right there. I'll label it. And you can see that it's rise 3, run 1, rise 3, run 1. So that's correct. All right, now we want to find the midpoint of JK. For B, we want to find the midpoint of JK using the midpoint formula. And we're going to label that and call it N. So N equals 4 plus 0 over 2. And the y value is 2 plus 0 over 2. And we get the midpoint N of 4 plus 2 is 6, divided by 2 is 3. And 2 plus 0 is 2, divided by 2 is 1. So our midpoint of JK, we're hoping, is at 3, 1. Let's see. 1, 2, 3.
You put a 2 first.
Oh, what did I do? Oh, I put a 2. Why do I keep doing that? It's a 0. My mistake. 4 plus 0 is 2. Okay, my mistake. Thank you. 1, 2, 1. All right. So that is N. Now, I wish I had a straight edge, but get a nice straight edge, connect those 2 points, and that should be my mid-segment. MN should be the mid-segment of triangle JKL, because we know N's the midpoint of this side, and M is the midpoint of this side. All right, now we're going to prove that line segment MN has the same slope as line segment LK. And we do that using the slope formula. So let's do MN first. Remember, slope formula is delta y over delta x, or the difference in y's over the difference in x's. So here's your point M. Here's your point N. So it's going to be 3 minus 1 over 1 minus 2, which means the slope of MN is 2 over negative 1, or simply negative 2. Oops, sorry. Let me bring that up a little bit. 3 minus 1 over 1 minus 2, which is negative 2. Yes? After the lecture. And we can check it just by counting 2. So from M to N, you've got to go down 2 and over 1, which is a negative 2 slope. All right, let's find the slope of LK now. And just a reminder, L I'll write it right here. L is at 2, 6, and K is at 4, 2. All right. So the slope, remember, it's the difference in y's over the difference in x's. So we'll go 6 minus 2 over 2 minus 4. And that's 4 over negative 2, which hopefully you realize reduces to negative 2. So we know that MN is parallel to LK. But we already knew that because MN's a midsegment, right? We just proved it. All right, now we're going to use the distance formula to prove that MN is half the length of LK. Remember, here's M up here and here's N there. It's going to be out of the picture, but just remind you where we got those. All right, so the length of MN, we write MN without a line above it. That means length. Equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Plugging in our info now, MN equals the square root of, I'm going to go 2 minus 1 squared plus 1 minus 3 squared, which gives me 1 squared plus negative 2 squared, which means MN, the length of MN is simply 1 plus 4, or the square root of 5. Okay, now let's find the length of LK. Remember LK, the points are right there. So LK is equal to the square root of, you got to write the formula, x2 minus x1 squared plus y2 minus y1 squared, which means LK is equal to the square root of 4 minus 2 squared plus 2 minus 6 squared, which means LK is equal to the square root of 2 squared plus negative 4 squared, which means LK is equal to the square root of 4 plus 16. So LK is equal to the square root of 20. So remember, 20 is 2 times 5. A 2 is going to get out, a 2 is going to get killed, and a 5 stays in, which means LK is equal to 2 root 5. Hopefully you can see that LK is twice as long as MK. So down here, the length of MN, the length of line segment MN, is half the length of LK. From your work in Part D, explain mathematically why this is true. Well, I don't know if we need to explain it. I guess we could say that line segment MN is equal to LK. Wouldn't that be? If this is 1/2, we multiply it by 2, they'd be equal, right? Make sense? And if we simply plug in, what will we get? I don't think that could be any clearer, could it? Or if you want to do it the way we wrote it originally, you could say MN is equal to 1/2 LK, and then we go square root of 5 equals 1/2 2 root 5, and obviously those two cancel each other. You get the square root of 5 equals the square root of 5, doesn't it? So your job this weekend is to do number 2 and 3. Pretty simple right there. You guys have about 20 minutes. Should have no problem finishing up in class right now if you were diligent young students and did not want to have homework.